So today it's an Algebra 2 class that we're doing, and we're looking at exponential growth functions and how to graph exponential growth functions. So today we're going to be looking at two different types of exponential functions. There are exponential growth and exponential decay. We're going to be focusing today on the exponential growth equations. Both equations are of the type y equals a times b to the x, where a and b are both constants with b greater than 0. First, let's look at the term b to the x for b equal to 2. And let's go ahead and find some values. Let's pick some values for x, and let's find out what happens with 2 to the x. Let's start with x equal to -3 and continue going by integers up to 5. Okay, so if we use -3 for x, we get 2 to the -3rd, which of course we know means 1 over 2 to the 3rd, which is 1/8. And now when we use -2, we have 2 to the -2nd, which we know is 1 over 2 squared, which is 1/4. And then we have 2 to the -1, which is 1 over 2 to the 1st, which is just 1/2. Finally, 2 to the 0, anything to the 0 power is 1. And then going through powers here, 2 to the 1st is 2, 2 to the 2nd is 4, 2 to the 3rd is 8, 2 to the 4th is 16, and 2 to the 5th is 32. Notice that no matter how small we choose x, 2 to the x is never 0. As we look at these values for x that are negative values, our corresponding value of 2 to the x is just a fraction. And as we would continue, this fraction would get smaller and smaller, that is, closer and closer to 0. Let's use these values for x to graph 2 to the x. So we've set up an x and y axis here, and let's go by a scale of 1. We're not going to get all of the points on here, but we'll see what happens with it. So when x is -3, y is 1/8. So down here, and 1/8 is just barely above that x-axis. When x is -2, we're up to 1/4, which is just very slightly larger. I'm going to put my scale here. Okay, when x is -1, we're finally almost visibly able to see it. It's at the half scale mark. X is 0, we're at 1. And let's continue our pattern. 2, 4, we have 1, 2, 3, this is 4, 5, 6, 7, 8. And 416 is going to be off the graph, but we can see that this graph is a curve. Notice that as x gets smaller, my values for y get closer and closer to 0. Now let's talk about the domain and range. Remember, the domain are the values that we can put in for x. We can use any value for x, so the domain is all real numbers. The range are the y values. What y values do we get when we put these values in for x? Notice that as x gets larger, y gets larger. But as x gets smaller, y gets closer and closer to 0. And in fact, it never passes 0. So our range is going to be all of our y values are greater than 0. We'll never pass this x-axis. Since y increases as x increases, we call this exponential growth. And this is going to be the case whenever b is greater than 1, the function will be exponential growth. So as I'm looking at this term here for b, if it's greater than 1, we're going to have an exponential growth graph. Okay, one feature that this graph has, that all exponential graphs have, is a horizontal asymptote. Notice again that this x-axis here, y equal to 0, is a boundary of sorts to our graph of y equals 2 to the x. The values, as x gets smaller and smaller, the values of y get closer and closer to y equals 0, but they never pass it. So this value here is what we call a horizontal asymptote, y equal to 0. It's the value that y approaches as x goes off to negative infinity. We also have horizontal asymptotes when y goes off to, or when x goes off to positive infinity. We also have horizontal asymptotes, so we'll look at that the graph jumps back and forth over the asymptote, but eventually approaches that horizontal line. In this case, as x goes to negative infinity, y gets closer and closer to 0. Let's take a look at some more examples of graphs of exponential equations. This time we're going to look at the graph of f of x equals 2 times 3 to the x. And we're going to actually just plot 3 points, also drawing on our knowledge of the shape of what an exponential graph should look like. So let's see how that looks. We're going to choose a negative value. Let's choose -1. We're going to choose 0, -1, 0, and 1. Let's try that again. When x is -1, we have 3 to the -1, which is 1/3 times 2. So that's going to be 2/3. When x is 0, 3 to the 0 is 1, so 1 times 2 is 2. And when x is 1, we have 3 to the first is 3 times 2 is 6. Let's graph those values and see what we get. At -1, we're at 2/3. At 0, we're at 2. And at 1, we're at 6. 1, 2. We know we're going to have a curve, and it's going to go up to infinity very quickly at the positive side here. As x goes down to negative infinity, we know that these values are going to approach 0. So our domain for this function is all real numbers. The range, again, is y greater than 0. Our horizontal asymptote is the x-axis, y equal to 0. And now we're going to remember transformations when we have a transformation of a graph. We have 2 multiplied by the graph of 3 to the x. So if y equals 3 to the x is our parent function, then that multiplying by 2 is a vertical stretch of 2. Let's take a look at another graph. Let's take a look at g of x equals 2 times 3 to the x minus 2. Notice, by the way, that our exponential portion, 3 to the x, is the same as it was here. Let's choose the same values for x. If x is -1, we have 3 to the -1, which is 1/3 times 2. And then we have to subtract 2. So 2/3 minus 2 is -1 and 1/3. Substituting in 0, 3 to the 0 is 1, 1 times 2 is 2, and 2 minus 2 is 0. And then substituting in 1, 3 to the first is 1. 3 to the first is 3, times 2 is 6, minus 2 is 4. Let's graph and see what this graph looks like. -1 is -1 and 1/3. 0 is at 0, and 1 is at 1, 2, 3, 4. Well, now that's strange. We've crossed over the x-axis. Why did we cross over the x-axis? Well, if we remember in our transformations, a -2 here is going to move the graph down 2 units. And so instead of our horizontal asymptote being at x equals 0, it's now going to be, at y equals 0. It's now going to be at y equal -2. This will be our new horizontal asymptote. So our graph comes here. It comes down. It's going to curve quickly and approach the horizontal line y equals -2. Our domain again is going to be all real numbers. We can use any real number for an exponent. So 3 to any real number gives us a real number back. Our range now, since everything has been shifted down on this graph, our range is now y greater than -2. Our horizontal asymptote, as we said, is y equals -2. And our transformations, we actually had 2. We had multiplying by 2 and then down 2. So we have a vertical stretch of 2 and then a translation down 2 units. Let's take a look at the equations of these two functions that we graphed here. F of x was 2 times 3 to the x, and g of x was 2 times 3 to the x minus 2. What's the difference between these two graphs? The only difference is that this graph is shifted down 2 units. If I take each of my y coordinates here, if I shift them down 2 units, I'm going to get these y coordinates. 2/3 minus 2 is -1 1/3. 2 minus 2 is 0, and 6 minus 2 is 4. So we can see that this graph is a vertical translation of f of x. So now let's go ahead and let's look at two more graphs. We're going to use transformations to graph these two functions. So instead of plotting points, we're just going to use transformations. In order to do that, we have to identify the parent function. So for f of x, we have 1/3 times 2 to the x minus 3. Our parent graph is going to be y equals 2 to the x. Well, y equals 2 to the x was the graph that we graphed in our first example. So let's take a look at that example again. We graphed these points for x and y and have this graph. So let's use a few of those points again to get our graph for our parent function. We're going to look at when x is -1, y is 1/2, 0, 1, 1, and 2, and maybe even 2 and 4. So let's go ahead and graph y equals 2 to the x. Let's move it over here and have our x-axis down here. So graphing our parent function, when x is -2, y was 1/4. When x was -1, y is 1/2. And x is 0 is 1. Then we had 1, 2, and 2, 4. We could also graph 3, 8 if we want. So let's do that. Here is our parent graph. Okay. Now, what is 1/3 going to do to all of these points? Well, the 1/3 is going to multiply all of the y coordinates by 1/3. So our first transformation is a vertical shrink of 3. That is, all the y coordinates are multiplied by 1/3. A shrink of 3 is a multiplication of 1/3. Okay, so let's do that. Let's take all of our y coordinates and multiply them by 1/3. Here's 8. 8 times 1/3 is 8/3, which is 2 1/3. 4 times 1/3 is 4/3, which is 1 1/3. 2 times 1/3 is 2/3. 1 times 1/3 is down here at 1/3. And a half times a third, wow, that's going to be a sixth, and we can just barely see that that's going to be above the axis. So let's graph that graph. We can see that this vertical shrink makes the graph less steep as we start. Okay? Now we have another transformation. This transformation is done to the x, and all of our x transformation are always in the opposite direction because it's an idea of undoing. So when we have x minus 3, we have a translation 3 to the right. So we're going to move each of these points 3 units to the right. Let's do that one in pencil. So take our red graph here, move each point 3 to the right. So 1, 2, 3. Move this point 3 to the right. 1, 2, 3. And again, 3 to the right. 1, 2, 3. And 1, 2, 3. And we see our new graph here moved over 3 to the right. So here's our final graph of f of x. Okay, let's do another one using transformations. We have f of x equals 1/3 2 to the x plus 2 plus 1. We see a couple of things that were the same as our graph before. We have our parent function is y equals 2 to the x. And so let's start with that again. Two to the negative 1 again is 1/2. 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. And 2 to the third was 8. And of course, we could take it one more point. 2 to the negative second is 1/4. So here is our parent function. And then we did the first transformation, which is the same. It's the 1/3 vertical shrink. So we have a vertical shrink of 3. That is, the y coordinates are multiplied by 1/3. Write it that way. Y coordinates multiplied by 1/3. Okay, there we go. So let's do that again. Each one of our y coordinates multiplied by 1/3. Well, a half times a third is a sixth. 1 times a third is 1/3. 2 times a third is 2/3. 4 times a third is 4/3 or 1 1/3. 8 times a third is 2 2/3. And we have this graph. Same as we had here. Okay? And now we have the translations. We actually have translations in 2 directions. Our x plus 2 moves it 2 units to the left. And our plus 1 here is going to move it 1 unit up. So let's do that. Let's take all of our red graph here, which represents our shrink, and move them 2 to the left and 1 up. So let's see if we can do that. 2 to the left and 1 up. 2 to the left and 1 up. Again, 2 to the left and 1 up. 2 to the left, 1 up, and 2 to the left and 1 up. Here is our graph of f of x, our final graph. And in each of these two cases, let's go ahead and write down what our domain and range are. We didn't do that. So let's go back to this one. Our domain was all real numbers. Our range, the x-axis is our boundary, so y is greater than 0. And our horizontal asymptote was y equals 1. On this one, our domain, all real numbers. Our range, well, notice now in our final graph here that our y values have been all shifted up 1, and so now my boundary and my horizontal asymptote is up 1, so our range is y greater than 1, and our horizontal asymptote is y equal to 1. And that's graphs of exponential growth models for Algebra 2.